Schrödinger's cat is one of the most famous thought experiments in physics. It was created by Erwin Schrödinger in 1935. In the years before, Erwin Schrödinger and other physicists had developed new theories about quantum mechanics. Their theories revolutionized physics as they were able to explain the processes in atoms. To give you more detail about it, actually negative and positive charges attract each other, but in an atom the negatively charged electron doesn't crash into the positively charged atomic nucleus, which would obviously be a problem. Quantum mechanics can provide an explanation for this dilemma. However, the theories about quantum mechanics still remain strange as they contradict our everyday experience and our logical understanding. And this is exactly what Erwin Schrödinger wanted to illustrate with his thought experiment. So the thought experiment is based on a quantum mechanical theory that particles can superimpose and assume multiple states at the same time. The reason for this theory is, among others, the double-slit experiment. In the experiment, small particles like electrons are shot through a double slit. On the projected surface, not two lines are formed as expected, but several lines, a so-called interference pattern. This pattern can only be explained by assuming that the particles behave like waves. Because, as you can see, when waves flow through a double slit, they overlap and subsequently form such an interference pattern. So the scientists made a few variations in this experiment and found out the interference pattern is even formed when the small particles are sent through the double slit one by one at large time intervals. Therefore, one must assume that each small particle forms its own wave, can superimpose itself, and thus is quasi at several places at the same time. So the small particle forms a superposition in which multiple states are possible at the same time. Like, what the fuck? But anyways, for an atom which is in such a superposition, the following applies. It can have several positions at the same time, point in different directions at the same time, or what is important for the thought experiment Schrödinger's cat, decay or not decay. But that's not all, it gets even more complicated. The double-slit experiment could also show that if one tries to measure or somehow observe the state of the particles magically form two normal stripe patterns and apparently no longer take a superposition. So the superposition of particles is only possible if there's no observer. Honestly, I have no idea why that is, but apparently it is. For the thought experiment, all you really need to remember is that according to quantum mechanical rules, an atom can be in a superposition and can decay and not decay at the same time. And this superposition can be cancelled by an observer. Okay, now let's move on to the thought experiment. In a locked box there's a cat, obviously, a radioactive particle, a measuring device that measures the radioactive decay, a bottle with poison, and a hammer that is connected to the measuring device. In our world, two things can happen now. The radioactive particle could decay, which is measured by the measuring device, which then triggers the hammer to destroy the glass bottle with the poison. The cat would then die. The particle could also not decay, then the hammer would not destroy the glass bottle, and the cat would remain alive. But if we don't observe the radioactive particle in the experiment, the particle takes a superposition and is decayed and not decayed at the same time. Since the life of the cat is decided by the decay or non-decay of the atom, the question arises which state the cat has when the atom has decayed and not decayed at the same time. Can the cat be alive and dead? Of course, Schrödinger's cat is only a thought experiment. It is not realizable because the cat as an animal is too complex to be brought into a superposition. Nevertheless, the experiment illustrates very well how strange quantum mechanics is. In our everyday life, things always only have one state, which is also very good, so I would claim. And nevertheless, our everyday life would probably not be possible if small particles could not take these superpositions. Quantum mechanics is very strange but also interesting and somehow gives us an even deeper understanding about life. I think especially in the future, quantum mechanics will advance even more and play an important role. So anyways, bye.